Hello, I'm Corbin Wonauer, a 10th grade member of the DuBois Area Team 1425, and I'm going to show you how we implemented Simulink for Best Robotics this year. First, to route all the needed controls for simulation, we implemented a signal bus so that this complex code would be readable. Our code centers around 4 separate driving modes that are selectable by the driver. To switch modes, a driver presses 8U. This subsystem activates and determines the active mode by which 7 button is pressed when 8U is released. Our default mode is tank drive. In it, joystick outputs are modified by a custom function to allow more precision for small deflections, while still permitting full power at max deflection. Deadbands and rate limiters are used to further modify the signals. At driver request, to increase precision further, we included a speed selector that switches between 2 different speed reductions. The arm is a dual motor winch that is controlled by 2 digital triggers and 2 limit switches. The limits prevent driver errors and physical damage to the robot. The claw servo is operated by 2 digital buttons that move it consecutively through 4 predetermined positions. To prevent accidentally cycling past a position, the claw only moves once per button press. The servo positions are assigned in a stateflow block and were determined by running the code in external mode. The light pulse servo control is very similar to the claw control. A few of our drivers prefer to use arcade mode, which implements the arcade mode block to alter the steering of the robot. Our original autonomous routine uses timers to control the robot's movements. Here in the state flow, you can see the various segments and the timings for when the robot's transitions between them. The second to last transition is triggered by the arm reaching the lower limit switch. The infrared encoder autonomous is essentially the same as the time-based one, but the state transitions and motor signals are controlled by preset target distance and P-loops. In this subsystem, the encoder values are converted to a distance which is compared to the target distance. The P-loop then applies a variable motor signal based on the difference. Additionally, each wheel speed is monitored and adjusted by a separate P-loop to keep the robot driving in a straight line. In addition to coding our physical robot, we also use Simulink to complete trials in the online programming skills competition. A sample of one of our trials is shown here. It uses the robot's position to calculate target headings and distances. It then uses a complex stateflow block with multiple PID loops controlling the motors.